Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 2.3, which is going to deal with solving for a variable. So we're going to continue our exploration through solving, except today we're going to be solving for a variable, which at first may sound normal because we usually solve for x or y or whatever letter. The difference for today is that we're talking about formulas that have numerous different variables, and we're solving for one variable. So, most of our answers today, you will not get an end result of a just nice number. In fact, you're going to get an end result that has a bunch of different letters and operations in it. So we'll go through and practice. I'll give you a different situation for a lot of different ones for you to reference for your homework. So, our learning goal for today is you will be able to solve an equation or formula for a variable. So for example 1, I'm going to give you an equation. You're going to go through and solve it for a variable. Example 2, we're going to look at some formulas. And then example 3, we'll take those formulas and actually plug some numbers in. Now, literal equations are equations that contain two or more variables. There are many literal equations in math, science, and engineering. Most equations are solved for one variable that is isolated on one side of the formula. We're going to use our solving skills to rearrange the formula to solve it for another variable. It's no different than solving equations. Okay, that's something I want you to know. That this is going to look different, it may feel a bit different, but everything you have done before for solving equations is the same as this. It's just you don't simplify after you add, subtract, multiply, or divide. It just stays that way. Okay? Alright, so with that said, I kind of like to do a little bit of a brief introduction into it. Okay, if we look at the equation, 6x equals 42, how do we solve this equation? Okay, you're going to look at it, and we're wanting to solve for x, so we ask ourselves what is happening to x. Well, 6x implies 6 times x, so to solve it, I have to do the inverse, or the opposite, which is going to be divide 6. Okay, so when I divide 6 to both sides, it goes away on the left side, and then we do 42 divided by 6, and we get x equals 7. So why did we divide by 6? We did that to get x alone, which we then accomplished. We did the opposite of what was happening to then get x alone and get our end result. So today, when it asks you to go through and solve for something, highlight what the variable is that they want you to solve for, and then you're going to undo what is happening to that. Okay? So if we took a look at this. So using the ideas for what we just talked about above, we want to go through and solve the following situation regarding the volume of a rectangular prism. In the formula, volume equals length times width times height. The variable h needs to be isolated, meaning I need to get h alone. So I need to go through and solve for h. So my end result, we should have h equals something, and that's what we are looking for. So there's no numbers involved in this. There's not going to be a number answer at the end. In fact, we're going to have another formula at the end, how to find the height when we know the volume, length, and width. So using this formula as our starting point for this problem. Okay, I know that volume equals length times width times height, and I need to solve for h. So I'm going to highlight h, I'm going to circle it. Okay, you're going to ask yourself, what is happening to h? Well, h is being multiplied by L and W, okay, just like we had up here, where x was being multiplied by 6. Up here, when we were multiplying by 6, I did the inverse, which is divide by 6. So if h is being multiplied by L and W, I have to do the inverse, which means I'm going to divide by L and W. And I have to divide by L and W to both sides. So when I do that, because I have L's in common on top and bottom on the right, and W's in common on top and bottom on the right, those cancel out. So then when I go to rewrite this, I have V equals LW over H. Now, before we say that we're done and finish, I just want you to take a look real quick. Is H alone? Have I gotten H completely isolated? In this case, I have. Therefore, my final answer is V equals, or V over LW equals H. Or we could write this as H equals V over LW. Okay, if you want to put the isolated variable first, just flip it and that works. So that is really going to be the essence of what we do today. Now I'm going to run through a host of examples to give you a look at what different situations are going to look like. And that's really kind of the main purpose. Just like I did with section 2.2, where I talked about different times in what the equations look like, I want you to see what it looks like when we go through and solve different scenarios. So I'm going to move this up for example 1 as we take a gander at our stuff for today. So we have parts A through F. We're going to run through most of them. Let's take a look at part A first. So for example 1A, we have y equals x minus 7, and they want us to solve for x. So we need to solve for x in this problem. So again, like I usually like to ask, what is happening to that variable that we need to solve for? So what's happening to x? Well, on that side of the equation, we have x minus 7, so it's being subtracted by 7. So to undo that subtraction, we need to do the inverse, which is add. So we're going to add 7 to both sides of the equation. And then when I do that, if we do y plus 7, okay, it's just y plus 7. Because these are not like terms, it just stays as y plus 7. And then the 7s are going to cancel out on the right. And we end up with x on the right. X is alone. It's isolated. So y plus 7 equals x. And I have solved this equation for x. All right, so let's take a look at B. For part B, we have C equals 12D, and they want me to solve for D. So D is what I'm trying to solve. So if we have C equals 12D, that implies 12 times D. So D is being multiplied by 12. So the opposite of multiplying 12, the inverse, would be to divide 12 to both sides. When I do that, I get C over 12 on the left. 12s cancel out on the right. And I'm just left with D. D is now isolated. And that is my final answer. That C over 12 equals D. All right, so those are a couple one-step solving. Now we're going to kind of ramp it up to two-step solving for our next problems. All right, for C, we are going to have G equals 3J plus 4. And for this problem, they want me to solve for J. So I need to get J alone. So what is happening to J? Okay, it's 3J plus 4, so J is being multiplied by 3 and added by 4. Remember, if we were actually plugging numbers in, we would use PEMDAS of order of operations, we're going to do the reverse of PEMDAS. So we're going to add or subtract first, then multiply or divide, and then exponents or parentheses. So let's add or subtract first. Because this is a plus 4, the inverse operation, the opposite is to minus 4. So when I do that, the 4's cancel on the right. On the left, we're going to end up with g minus 4. I cannot combine these because they're not like terms. And then I am left with a 3j. So I now have g minus 4 equals 3j. Now I still don't have j alone. So it's a 3j. 3j represents 3 times j. So the opposite would be to divide by 3. So the 3's are going to cancel on the right. And then I am left with g minus 4 over 3 equals j. Everything is canceled out on the right, so I'm left with j. Now, you could go through and break this down a little bit more, but we're just going to leave it as g minus 4 over 3 instead of dealing with improper or compound fractions. So, g minus 4 over 3 equals j is my final answer for that problem. All right, if we take a look at D, so for D, we have f minus 7 over g equals h, and we need to solve for f. So in this problem, we are going to solve for f. Again, we have f minus 7 over g equals h. Now, like I have mentioned before, we do reverse order of operations. But if you think back all the way back to section 1.1, when I said you have a giant or a whole fraction on one side, when one whole side is a fraction, you have to undo that fraction before we can add or subtract. Okay? I cannot just add 7 and make this f over g equals h plus 7. That does not work because I have an entire fraction on one side. If this was f over g minus 7, then I could do that. But I cannot do that for here. So I have to multiply by the number that I have on the bottom first, in this case, g. So we're going to multiply g to both sides. So right there. So when I do that, the g's are going to cancel out on the left. I'm left with f minus 7 equals, this is h times g. You can leave them separated if you want. I'm going to write them as hg because that represents h times g. Alright, so I have f minus 7 equals hg. Now I can go through and add 7 to both sides. So the 7's cancel out, and I get f equals hg plus 7 as my final answer. So my final answer is f equals hg plus 7. Now, if you were wanting to go through and add 7 first, the case that you could do that is if you had f over g minus 7 equals h. Okay, in this case, you could add 7 first because I do not have an entire fraction on one side. So you would have f over g equals h plus 7, and then you would multiply. But because I have an entire fraction on one side, I have to multiply g first, then I can add. All right, let's take a look at our last two parts for example 1. So for E, I have 12r minus 6s equals t, and they want me to solve for r. So what's happening to r? It's 12 times r minus 6s. So again, I'm thinking reverse order of operations. So because this is minus 6s, I need to do the inverse, which is to add 6s. And please know that that is a 6s, not 65, for how I write it. So when we do that, the 6s cancels out on the left. I'm left with a 12r equals t plus 6s. And then because this is 12 times r, the inverse would be to divide. And we're going to end up with, because the 12s cancel out, r equals t plus 6s over 12. So r equals t plus 6s over 12. And that is your final answer. All right, last one. And F is a really important one to talk about because it's a bit different. So for F, we have h over j equals 15. And we want to solve for j. Now, it would be nice to be able to say, okay, h is on top. That means I need to divide. This is j equals 15 over h. That is not the case because j is on the bottom. If I were to divide by h, I still have 1 over j, and j is not isolated. So your first step to solve this type of problem, when you are trying to solve for a variable on the bottom, is to get rid of the fraction, meaning I have to multiply what's on the bottom first, so j. So when I multiply j to both sides, it cancels out on the left, which is okay, because j is still in the problem. And I get h equals 15 times j, or 15j. Now, I need to solve for j, as we've talked about. This is 15 times j. So all I have to do now is just do what I'm used to, which is divide. 15's cancel out. And we get h over 15 equals j. So please be careful when your variable is on the bottom, what you're trying to isolate. Multiply it first to get rid of the fraction. Okay, if there's no plus or minus afterwards, like this f minus 7 that I did for d, this extra problem, okay, in that case you can add first. Again, I have one whole fraction on the side. Get rid of the fraction and then solve. All right, so that is how you go through and do all the problems for example 1, parts A through F. If you need to relook at a problem, go back to that spot in this video or just take a look at my completed notes for some guidance. Now, if you need help, I completely understand if you need help with this section. You are more than welcome to ask me the next time you see me. Okay, this section, once you get some practice getting used to this looking different, it runs a bit easier. It just confuses you a little bit more because you have more letters. Okay, but just keep in mind, it's the same thing you've been doing. It's just you don't have a simplified answer at the end. Okay, but if you need help, please do not hesitate to ask. I'm here to help you. All right, so before we finish our video for today, we have a couple more examples to take a look at. Now, example 2 is going to be a lot of the same idea that we just went through with example 1. It just is the fact that we have formulas. So everything we talked about on the other side was just an equation. These are all real-life formulas. Formula for velocity, area of a triangle, circumference of a circle, and then sum of a triangle. Now, we'll go through and kind of run through these ones as well, just to give you a view of what your answer would be. All right, so for example 2a, the formula for velocity, we have v equals d over t, and we need to solve for d. So we need to get d by itself, because I have a fraction on the right side. What I'm going to do, and I'm going to rewrite this, To get rid of my fraction, I need to multiply by what's ever on the bottom of the fraction to both sides. So we're going to multiply t to both sides. So we multiply t to both sides. T cancels out on the right. T times v is tv, and that equals d. D is now isolated, so that is my answer. You could also write this as d equals vt. Okay, the order of the v and the t does not matter. Okay, because it's multiplication, you can flip them around. All right, for b, we have the formula for the area of a triangle is a equals 1/2 base times height. And we need to solve for b. So we're going to solve for b in this case. Now, your first step in solving this, okay, we're not going to try to do it all at once in this problem. First thing I like to do is try to get rid of the fraction. Okay, this 1/2, okay, implies dividing by 2. So the opposite to get rid of this fraction of 1/2 is to multiply by its reciprocal, which is 2 over 1, or 2. So we're going to multiply 2 to both sides, which cancels out the 1/2 and the 2, because 1/2 times 2 is 2 over 2, or 1. And then on the left, I get 2a equals bh. And then because I am solving for b, I need to get rid of the h. Because it's multiplication, we're going to do the inverse, which is division. So the h's cancel out. And we get 2a over h equals b. So that is how we're going to go through and rearrange the formula for the area of a triangle to solve for b. Same idea as if you were solving for h, it's just that b and h would be in different spots. All right, so moving on, let's take a look at c, which is going to deal with the formula of circumference of a circle. And in fact, I'm actually going to pull back down parts A and B so you can reference them if need be. So for C, we have the formula for the circumference of a circle is C equals 2 pi r, and we need to go through and solve for r. Remember, pi is just a symbol for a number, and a specific number. Pi, just to a certain number, is 3.1415926, and so on. Okay, so think of pi as a number when we're doing this. Okay, so C equals 2 pi r. That means 2 pi times r. So to get r alone, that means I need to go through and divide 2 pi to both sides. So I divide pi to both sides to get r alone. So 2 pi cancels on the right. And we're left with C over 2 pi equals r. And r is isolated, therefore that is my answer. So to solve for r in the circumference of a circle, you go through and divide by 2 pi, and you get C over 2 pi equals r. Okay, so if we take a look at D, so for D we have the formula for the sum of angles in a triangle is angle A plus angle B plus angle C equals 180. Means all the angles add up to be 180. And we need to solve for C. So let's ask ourselves what is happening to C. It's A plus B plus C, meaning we could really write this as C plus A plus B. So C is being added by A and by B. So to solve for C, first step is we're going to subtract A. Because it is a positive A, we can subtract it. So then I have B plus C equals 180 minus A. And then for this side, again, I need to get C alone, so we're going to subtract B to both sides. I subtract B because it's positive. And we end up with C equals 180 minus A minus B. And that is our answer for example 2D for isolating C in the formula for the sum of angles in a triangle. Okay, so we've run through a lot of problems today. Example 3 has 2 parts to it. I'm only going to run through part A because you can always look at my notes for part B, but I do want to run through example 3A just so that way you have seen it. So I'm going to move this up so we can see example 3 for part A. So for example 3A, we have a sinker on a fishing line is made of lead and has a volume of 0.000015 meters cubed. What is the mass of the sinker? So we're going to go through and find out what the weight of the sinker is when we know that it has a volume of this. Okay. Now, I know you may be sitting there going, well, that's great and all, but I don't know really how much lead weighs. Well, as matter has it, I have provided density for lead, which you'll use for part A. For part B, that you would go through this problem, you would use the plastic measurement for that. Alright, so the density formula can be rearranged to isolate for M. So that means we're going to solve for M because we're going to try to find the mass. The values for volume and density can then be substituted into the formula. Okay, I've provided the density, so this is D, and then we've also been provided the volume right there. Alright, so to do this, we need to go through and solve for M. To get M alone, we're going to multiply and get rid of this fraction, so we're going to multiply V to both sides. So when I do that, the V's cancel on the right, and I get V times D equals M. So to figure out the mass of that sinker, okay, I'm going to plug this number in for V and this number in for D, and we'll go through and multiply. So the volume is 0.000015, and the density is going to be 11,340. And that is going to equal the mass. Now, I don't know off the top of my head what that multiplication is, so I'm going to use my calculator to do this. So we're going to do 0 point, and then we have 4 zeros, so 0.000015 times by 11,340. And we're going to end up with 0.1701. I'm going to round to 2 decimal places. So then that means I get 0.17. Because we're talking about mass, we're going to have kilograms for the mass of the sinker. And that is your answer for example 3, part A. Now, part B, you would go through and do the same thing, rearrange it for the volume, use the density, use the mass that they provide you, and then you should be able to go through and find the volume of the plastic foam. Alright, so with that said, like I mentioned before, I will leave part B for you to do. If you want some guidance, just ask me later, or take a look at my completed notes for some direction. So, with that said, that is your video and your lesson for section 2.3 on solving for a variable. I understand this feels different, feels weirder. Okay, this is the only time this comes up, but it's something that's helpful and useful for really real life problems and science or engineering problems. Okay, if you need help and some guidance through some problems or some starting points, by all means, just let me know and I will help you. Or by all means, come back and rewatch the video, look at my completed notes for some guidance on how I did each problem. So, that is all that I have for you guys today on section 2.3. Thank you for watching. If you have any questions, just shoot me an email or let me know, and I'll be more than happy to help. All right, that is all for today. Thank you and have a great day. Bye.